these formulas we have already derived in the previous lecture, and there we said that first of all we need to find dE prime by dt prime and the expression of dt prime by dt, and then we will insert the both expressions in these formulas and we will get the final results. So first of all we are going to find dE prime by dt prime. dE prime by dt prime. So what is E prime? Now E prime is the energy of the particle in S prime frame. So E prime, as we know that energy is written as E square is equal to P square C square plus M naught square C power 4, where P is the momentum of the particle, M naught is the rest mass of the particle, and E is the energy associated with that particle. So over here this P can be written as P vector dot product with P vector. So this P square can be written as P vector dot product with P vector. Here we want to find E prime. So what will be E prime square? That will be equal to P prime square C square plus M naught square C power 4 as it is. So this P prime can be written as P vector prime dot product with P vector prime times C square plus M naught square C power 4. And now we are going to do its time derivative because we want to find dE prime by dt prime. So now we will do the time derivative. So that will be 2E prime into dE prime by dt prime. So I have taken the time derivative of the left hand side and that will be equal to this factor. So this will be equal to P vector prime as it is. So C square will be as it is outside the bracket. So this C square will be outside the bracket, and we are going to do the time derivative of this factor P vector prime dot product with P vector prime. So this will be equal to P vector prime dot product with dP vector prime by dt prime plus dP vector prime by dt prime dot product with P vector prime. So this is how you take the derivative of a dot product, and time derivative of this one will be equal to 0 because this is a constant. M naught is the rest mass of the particle when its velocity is 0. So this is a constant, it does not change with time, so its derivative will be 0. And these two terms are identical, so this can be written as C square as it is twice of P vector prime dot product with dP vector prime by dt prime, and on the right hand side, on the left hand side, you will have twice of E prime into dE prime by dt prime. Now this E prime can be written as we know, E prime can also be written as M prime C square, mass of the particle in S prime frame, times C square. So this E prime can be written as M prime times C square. So C square will cancel and this 2 will cancel on both the sides. Now take this M prime on the right hand side, you will get dE prime by dt prime is equal to P vector prime dot product with dP vector prime by dt prime as it is. Now this M prime will be taken on the right hand side, so this will be divided by M prime. So now we have found dE prime by dt prime. So we wanted to find dE prime by dt prime, and that has come out to be equal to this factor. Now this P vector prime by M prime. Now P vector prime, this is nothing but equal to mass of the particle times the velocity of the particle in the S prime frame. So P prime vector is equal to the mass of the particle in S prime frame times the velocity of the particle in S prime frame, which is nothing but U prime vector. So P vector prime divided by M prime, this factor will be nothing but equal to U prime vector. So this will be nothing but U prime vector dot product with dP prime by dt prime. So this is nothing but time rate of change of momentum in S prime frame. So here we have dP prime by dt prime. So this is nothing but the force on the particle in S prime frame. So this will be nothing but F prime vector. So dE prime vector by dt prime will be nothing but the force on the particle in S prime frame. So dE prime by dt prime has come out to be equal to this term. Now we want to find dt prime by dt. So for that, let's find what is t. So from the Lorentz transformation, t is equal to gamma times t minus vx by c square. T prime is equal to gamma times t minus vx by c square. So from here, let's find t. So t will be equal to gamma times t prime plus vx prime by c square. So we have just used the inverse Lorentz transformation. So t will be equal to gamma times t prime plus vx prime by c square. Now we will find dt by dt prime. So that will be equal to gamma as it is. So dt by dt prime. So we are doing the derivative with respect to t prime variable. So here you will have 1 plus v by c square as it is and dx prime by dt prime. So we are just doing the derivative with respect to t prime variable. Now over here, this dx prime by dt prime, the derivative of position with respect to time is nothing but velocity. But over here, this is dx prime. So x prime is the coordinate in s prime frame and this t prime is the time parameter in the s prime frame. So dx prime by dt prime will be nothing but the x component of the velocity in s prime frame. So this will be equal to gamma times 1 plus v by c square into ux. So dx into ux prime. So dx prime by dt prime will be ux prime. But in these expressions, we want to find dt prime by dt. So we have found the expression of dt by dt prime. So what will be dt prime by dt? So that will be just reciprocal of this one. So that will be equal to 1 divided by gamma times 1 plus v by c square into ux prime. So now we are going to substitute these expressions in these three equations. So when you will substitute, you will get the final result, so that you will solve by yourself. So you will get the final result, fx is equal to fx prime plus v by c square. Instead of de prime by dt prime, you will insert u prime vector dot product with f prime vector. So u prime vector dot product with f prime vector. Divide by 1 plus v ux prime by c square. So this is the first equation that we have got of fx in terms of fx prime. Then you can find fy in terms of fy prime by putting the relation of dt prime by dt from here. So fy will be equal to fy prime divided by gamma times 1 plus v ux prime by c square. So this is the second equation. And last, fz is equal to fz prime divided by gamma times 1 plus v ux prime by c square. So this is the third equation. Now these three are the general equations of the relation of forces in two inertial frames. Now as we have said that at the end of the derivation, we are going to take S prime frame as the particle frame, the frame in which particle is at rest. So we have just taken S prime as the frame in which the velocity of the particle is u prime. But now we are supposing that this S prime is the particle frame. So S prime is the frame in which the particle is momentarily at rest. So at any instant of time, its velocity is equal to 0. So this becomes the particle's frame, means u prime is equal to 0. So ux prime is equal to uy prime is equal to uz prime is equal to 0. So these are the general equations in which the S frame is the frame in which the velocity of the particle is u vector, and s prime is the frame in which velocity of the particle is u prime vector. But now we are going to find these same equations when this s prime frame is the particle's frame, means the velocity of the particle is 0 in this frame at some instant of time. So what will be these equations when this s prime frame becomes the particle's frame at any instant of time? Means we have to put ux prime, uy prime and uz prime is equal to 0. So in this first expression you have u prime vector. So this velocity will be put equal to 0, and this ux prime in the denominator will also be put equal to 0. So this term will be equal to 0 and this term will be equal to 0. So when s prime is the rest frame of the particle, or you can say it is the particle's frame, so in that case fx will be equal to fx prime, fy will be equal to, so ux prime will be put equal to 0. So fy will be equal to fy prime divided by gamma, and fz will be equal to fz prime divided by gamma. So these three equations are the one in which the velocity of the particle in s frame is u, and velocity of the same particle in s prime frame is u prime. But when this s prime frame is the particle's rest frame, so particle is momentarily at rest in s prime frame, in that case you will get these three equations. So fx will be equal to fx prime, fy is equal to fy prime divided by gamma, and fz is equal to fz prime divided by gamma.